All right, welcome back to Module 6. Hopefully this is the last video you'll see. So let's continue on with the default gateway. Again, the default gateway is the interface on the router that is attached to the network. It's treated as a regular host, just like everyone else, but everyone in the LAN needs to know what the default gateway is in case they need to go outside the network. Okay? All right. So let's move on. It's probably a good idea to take a picture of this too, or write down these 4 bullet points about the default gateway. Okay, routing tables. The router itself will keep track of all the network and which interfaces you need to send them out. That's called a routing table. The PC has also a routing table. You can type the command route print or netstat R that can be used to display the host routing table. A routing table has information about where to send the data about a network about a device that you need to send the data to. Okay, so please write this down. That's very important. These 2 commands at least. Write these 2 bullet points about the routing tables. So here's a typical routing table on a Windows PC. So if you're trying to reach, for example, 192.168.10 with this mask, you should send out the data to this interface, 10.10. Okay? Metric is, I think it's how reliable it is, but you don't have to worry about the metric itself. If the device that you're trying to reach is not in the routing table, then your computer is going to say to you, network is unreachable, right? If you try to ping a device and you get the error message that says network unreachable, it means it's not in the routing table. But if you get the error that says timed out, that means the TTL number has reached 0. Router is outside your LAN, not your default gateway. Will tell you, your packet did not reach the destination because it has reached 0. The TTL number has reached 0. All right, let's take a look at IPv6. IPv4 was limited to 32 bits. So in 1998, IPv6 was ratified. IPv6 solved all the problems that IPv4 had. And the number 1 problem that they had is they didn't have enough IP addresses. It was only 32 bits IP addresses, the length of it. So 2 to the 32 is about a little bit more than 4 billion addresses. And as we've seen before, class D and E are not even used. And class A and B, and we have to manipulate them, do subnetting, and subnet mask is a pain. And we need to use private IP addresses to improvise and give us more IP addresses. So that gave us a delay. As the internet grew, everybody knew that we needed to really come up with something new. So that's where we got IPv6. Now we have 128 bits. So 2 to the 24 gives us 340 udecillion possible addresses. That means you will not going to be able to run out of IP addresses for years to come with IPv6. And that is really slowly replacing IPv6. And as you can see, IPv4, even in Africa, has been exhausted since 2020. So everything that you'll get from your ISP now is IPv6. The whole world is broken into, let me go back to this for a second, into 5 areas. The area for North America, that's including the United States and Canada. Then you got South America, Europe, Africa, and Asia. So if you live in North America, this is where ISP get their public IP address. If you live in Africa, you go to AfriNIC to get your IPv6 addresses and so on. All right, IPv6 was needed for the Internet of Things. Internet of Things is every device that needs to communicate, such as iPhones, iPads, your